Welcome to part 4 of the guitar pick tray series. Today we are going to go over our roughing operation, where the name of the game is to remove as much material as fast as we can. So we are going to use a 3D adaptive clearing toolpath to go ahead and remove that material. There are a couple interesting facts about 3D toolpaths and about adaptive clearing. So the interesting fact about the 3D toolpaths is Fusion 360 will consider the geometry of our model for us when we go into a 3D toolpath. The interesting fact about the adaptive clearing strategy is that Fusion 360 will try to keep an optimal load or constant engagement of our tool with the material. That allows us to optimize our speeds and feeds, and we don't run into any scenarios where if we take a corner, we would essentially potentially take off more material than what we were expecting. Fusion will do the math for us and make sure that our tool stays within that optimal load. Alright, so now we're going to go up to 3D and select adaptive clearing. We're going to choose our tool. So I'm going to go to my 770 library and I'm going to select the Gorilla 3/8 chimp breaker. So this is a 3/8 3-flute end mill. For all of the work that I do in aluminum, I go with 3-flute end mills. It has chip breakers, so that when I'm roughing, it creates a finer chip. There's two advantages to that. The big one is I don't end up with chip buildup all over my part and all over my vise, so I don't end up recutting chips and ruining the surface finish on my finishing operations. The other thing the chip breakers do is it relieves some of the tool pressure, so that allows me to run a little faster with this end mill than I could with a 3-flute end mill that doesn't have those chip breakers. So I really like this end mill for roughing, so I'm going to go ahead and select that. The next thing we'll do is go over the speeds and feeds. So I'm running at 7,500 RPM, and really for the 770 I find 7,500 to 8,000 RPM is really the sweet spot for machining aluminum. We'll be running at 60 inches per minute, and that puts us at almost 3 thou per tooth, where we are at 2.6 thou. We can skip over the geometry tab because it's a 3D toolpath, so Fusion is taking that into consideration for us. We'll jump into heights, and the big issue here I want to point out is our top height is set to stock top. And you'll remember from the previous operation we faced our stock, so we removed 50 thousandths from the top of our model. And if we leave this at stock top, we would essentially be roughing air. So we would be cutting air. That would waste a lot of time, and you'll see when we're finished setting up the toolpath, the roughing operation typically takes the longest time. So we want to be as efficient as possible to save machining time. So I am going to select model top for the top height, the retract height, and the clearance height. And again, this is just going to help prevent us from cutting air. Alright, so now we're going to go into the passes tab. And the main parameter here is optimal load. You can think of optimal load as width of cut or step over. And 150 thousandths is way too much for the Tormach. I want to keep that at around 10% the diameter of the end mill, and I'm actually going to go slightly below that at 8% for my Tormach. So I'm going to set this at 30 thousandths. The next thing we are going to notice here is I have stock to leave selected. So because we are trying to remove as much material as fast as we can, we're going to have tool deflection, and really at the end of our roughing operation, our part isn't going to be finished and in tolerance. So by leaving stock on both the floor and on the walls of our part, we're able to go through nice and slow with finishing operations, which you'll see in later tutorials, remove that extra stock and really bring our part in tolerance and provide a nice surface finish. So there are a couple parameters in the linking tab I would like to go over. So again, the roughing tool paths take the longest, so we want to avoid anything that will add extra time to that. So one of those would be our stay down level. So we want to keep that at least. The higher we go on stay down, we will introduce more retractions, and that will increase our machining time. The next thing we can do is the ramp clearance height. So when we are performing a helical entry, this would start the tool 100 thousandths above our material. So we would helical down 100 thousandths before we engage the material. I'm going to set that at 10 thousandths, and that will just, again, minimize the amount of air we are cutting. So that's it for setting up the toolpath. I'll go ahead and click OK. Now you'll notice in the background, Fusion has to do more math, so it's going to take slightly longer to generate the adaptive toolpaths, but there it is. We can see our part has been roughed out. I'm going to right click and then go to simulate. And again, if we look at the estimated time of completion compared to our face at 3 minutes, our adaptive clearing, our roughing strategy, is just a little over 15.5 minutes. So, drastically more than it took us to do the facing operation. So again, we want to keep that time minimized so we can be efficient. So what I'll do now is just go ahead and simulate. That's way too fast, so we'll slow it down. And you can see we're just walking around the part at a full depth of cut. So the height of our walls on the pick tray was 0.7 or 700 thousandths of an inch. We went below that by 50 thousandths earlier, so our depth of cut is 0.75 inches or 750 thousandths. All right, so I will speed it up just a little bit. I'll show you guys the helical entry, and then there are a couple points I would like to emphasize at the end of the toolpath. So there was the helical entry, and now we're just hogging out material in a circular motion in the center of our tray. And what I really want to emphasize here, okay, let's finish, is if we zoom in, you'll notice our end mill was too big to really get into those tight corners in the upper and lower horn, as well as out here, where if this was a real guitar, the neck pocket would be. So what we'll end up doing is performing another adaptive clearing toolpath, but with a 1/4 inch end mill, and then we'll go in and clean up all the excess stock and prepare our model for the finishing operations, where we will use that same 1/4 inch end mill. I do not have a tool changer, so anytime I have to manually, with the power draw bar, change the tool, it just adds machine time. So we will be finishing the roughing with the 1/4 inch end mill, and then we'll be performing a pocket tool path and a 2D contour tool path to finish the inside and the outside of our part with that same 1/4 inch end mill. All right, that does it for our first roughing operation.